have divided the chapter sets into 4 basic concepts. That is concept number 1, basic operations on sets, and concept 2, multiple basic operations on sets, and concept 3, drawing Venn diagrams for sets. Last, fourth concept, solving word problems based on sets. Comparison of questions based on concepts with questions from board question paper. Concept wise and marks wise discussion. Marks allotted for the chapter sets. Marks allotted for this chapter are 3, and questions can be formed like this: 1 mark question and 2 mark questions. Totally 3 mark question can be asked on this chapter. 1 mark questions. 1 mark questions based on concept 1, that is basic operations on sets. On right side of the screen you can see 3 questions. These questions are based on concept number 1. On left side of the screen you can see the questions, and these questions I have taken from our textbook, which are similar to board questions. Now 1 mark questions continued. These 1 mark questions are based on concept number 2, that is basic multiple operations on sets. Similarly, on left side of the screen you can see the similar questions. I have taken them from our textbook. Now 2 mark questions, and these 2 mark questions based on concept 2, that is basic multiple operations on sets. And left side of the screen I have taken similar questions based on the same concept from our textbook. 2 mark questions continued. These questions are based on the concept drawing Venn diagrams for sets. On right side of the screen if you see exercise 1.1 7th main. In 7th main you will get similar questions to this. Okay. Now 2 mark questions continued. Now these questions are based on the 4th concept, solving word problems based on sets. And in left side of the screen you can see exercise 1.2, 2nd, 3rd, 4th and 5th sums. These sums are similar to these board questions. And 2 marks questions continued. 2 more questions are there. Next, extra questions I have given for you. Find cardinal number of the set. What is cardinal number of null set? And what is relation between 2 sets along with union and intersection, and it is a standard formula also. Now what is relation between these 4 terms? If a condition is given, that is n of a and n of b are disjoint sets, and write De Morgan's formula for union and intersection of sets. Here in this video I will supply you the material for 3 concepts, 1st, 2nd and 3rd. But for the 4th concept you have to refer my one more video, and for that I have given link in the description box. Now question of the chapter: is it possible to find complement of universal set? So to understand whether you have understood the concept or what, this question is being given. If you know the answer, nice. Otherwise let me know in the comment box and get solution for this. Now I will show you how to perform basic operations on sets. This is our universal set. Universal set is denoted by U. This set has usually large number of elements. By taking few elements or all the elements from U, we will construct subsets. For example, subset A and subset B. In this set, here I have taken a box for universal set U, and it has colorful balls in this. Now instead of numbers I have taken here colorful balls. These balls will be our elements, and now I am constructing set A by taking few elements from universal set. Here you can see 4 elements I have taken from our universal set. Similarly, I'll construct the set B by taking few more elements from universal set U. Now we have constructed 2 sets, set A and set B. Now I'll show you how to perform basic operation union on these 2 sets. What is union? Union is also called as OR function, OR function. How OR function or union function is performed? First, you just mix both the elements. It is our union. But a small care is to be taken here. That is, you just remove the repeated elements from this set A. Repeated elements I am removing. Blue is repeated, green is repeated. So I have removed the repeated elements and we can give a new name to this union, or you can continue as A union B. Now green, grey, cream, pink, yellow and blue are elements of A union B. Please don't forget, just mixing is union. Now I'll show you how to perform intersection or AND function on 2 sets. Yes, this is our set A and this is our set B. What I'll do, just I'll remove the common balls from these 2 boxes. Common element is blue. It is there in both the boxes. I have removed. And green. Green is also there in both the boxes. Are these 4 elements are common? Yes, 4 elements are common, but will represent this intersection only by one set of elements. Here, green and blue are common balls from both the boxes, and these 2 common balls are called elements of intersection. I hope intersection is clear now. Okay, we'll move how to perform complement. To perform complement, we need one set along with our universal set. Fine. How to perform complement? Now compare our set B with our universal set. Just take out the common elements or common balls. Now I'll remove the common balls. Here green and blue. Here also I have green and blue. I'll remove those elements first. Now what are all the elements left in our universal set? You can see here I have left with 3 balls. Yellow ball, pink ball and grey ball. This grey, pink and yellow balls are the elements of A complement. Similarly, we can perform complement of B also. Next, I'll show you how to perform A difference B. Okay, to perform A difference B, I have 4 elements in the set B. Similarly, I have 4 elements, or you can have even 5 elements also in the set A. To perform A difference B, you just remove the common elements from both the boxes first. Here I have pink ball, I have removed it. I have grey ball, removed it. Yellow ball, I have removed. Now I have left with only 2 balls, green and blue. This green and blue are elements of A difference B. Similarly, if you consider B difference A, in that case refer the set B. Here I have left it only cream color ball. So this cream color ball will be the element of B difference A. In this way you can create your own boxes and color balls. It is very simple. By practicing in this way with these materials, you will be very perfect with the operations that can be performed on sets. Now we will see the second concept, that is concept of performing multiple basic operations on sets. Before going to perform multiple operations, first let us analyze the question, that is here A union B intersection C. 2 sets of operations are given and union is the final operation and intersection is the first operation. How? First, attack the area which is under bracket, that is B intersection C. So I have drawn here a flow chart, you can see clearly here. First, give importance to B intersection C, that is B intersection C. Then perform the operation of A with B intersection C. I'll explain you clearly with one example, that is A equals 1, 2, 3, these are elements, and B equals 2, 3, 4, C equals 1, 3, 4. Okay, you can see here clearly I have given number 1 for this operation and number 2 is final operation. Okay, first let me perform B intersection C. Intersection means taking out the common factors. So 3 and 4 are common factors, common elements. I have taken them outside. That will be our B intersection C. Now I'll perform this B intersection C, the operation of B intersection C with A, that is intersection again. So A means 1, 2, 3. B intersection C we have already found out, that is 3 and 4. Okay, to perform intersection let me take the common terms here. 3 is the common element, so I have taken 3 as a common element and this is our final answer. Similarly, A union B complement. So first you have to understand how to perform the complement, that is U difference A union B. Okay, this will be our final step, but before that let me perform A union B. Okay, that will be our first step. So here you have to start from the end point, that is A union B. Now if you perform union between A and B, you will get A, B, C, D, E as answer, because you will take ABC from A set and CDE from second set. It will be their union. Now to perform U complement or difference of A union B, write down U and write down A union B. Here you will find no problem because already you have found out A union B. So as it is I will write A union B here. Okay, To perform the difference function, first let me take out the common factors. These are common factors. After leaving the common factors, I will be left with only F, because A, B, C, D, E are common factors. So F will be our final answer, and that will be our A union B complement. Similarly, one more example I'll show you. A complement intersection B complement. To perform A complement intersection B complement, please don't do the step directly. Before that, you prepare complement of A. That is, to perform complement of A, you have to perform U difference A. Similarly, to perform complement of B, you perform U difference B. Okay, here I have made B complement, that is U difference B. I have taken all the elements of U, taken all the elements of B, and I have removed the common factors out of the bracket and selected only the elements from U. And the only elements from U are 1, 3 and 6. Similarly, I have performed complement of A, that is U difference A. I have written U, I have written A, and I have taken out the common factors, common elements. Those are 1, 2, 3, 4. Remaining those elements I have left with 5 and 6. Those are my complement of A. Now this is final step. See, in inverse way I have written 1, 2, 3. Now I am performing the third and final step, that is A dash intersection B dash, or complement of A intersection complement of B. So I have written complement of A as 5 and 6, complement of B as 1, 3 and 6, and I have taken common element as my answer, because the meaning of intersection itself is taking out the common elements. So 6 will be my final answer. In this way you can perform n number of questions. Now we will see the third concept, that is representation of sets by Venn diagrams. Before that, let me show you some basics. This is representation of a set in the area of universal set. This is union of two sets, intersection of two sets. Okay, now I'll show you how to perform an operation between two sets. Here, this sheet represents not a set, that is complement of A, and this sheet represents not B or complement of B. To get intersection of these two sets, you just keep these two sheets one over the other. You just make a close examination of these two sheets. Consider only the shaded area which is overlapping. Here in this case, only the area which is out of these two circles, that is shaded as well as overlapping. It means that will be our answer. So here it is one more thing to remember, that is while performing such operations, for your practice you just take two sheets, draw one set of operations in one sheet, take other sheet, draw the second set of operations, keep the sheets one over the other. If you want to have intersection, you just consider the area which is shaded as well as overlapping. To get union, you consider only shaded areas, no necessary to overlap. Now I will show you how to perform three set operations. Here I have drawn A union B. This set shows A union B. Now in this sheet I have shaded only C. It means I have taken only C. Okay. To perform operation of intersection between these two sets, I have to keep these two sheets one over the other. Okay. To get the intersection, you just make a close examination of these two sheets and take only those areas which are shaded as well as overlapping. In this case, only this area is shaded as well as overlapped. So this area is our answer. One more example. This is A difference B. You can perform A difference B on one sheet, and this is A difference C. Okay. To perform union between these two sheets, you just keep one sheet over the other, and as it is union operation, you consider all the areas which have got shade. It means here the whole area is shaded. Along with this, if you can see here, if you can see, this area is also shaded. It means this whole area along with this area. This is our answer. I am not so confirm here whether you can see through these transparent sheets the shaded area or shaded and overlapping area, but if you take such transparent sheets, do the same thing with yourself, definitely you will come to know what is shaded area and what is shaded and overlapped area. Only shaded area gives you the union, and shaded as well as overlapped area will give you intersection. Best practice of the study. Instead of practicing a sum by writing it many times, you just practice it one or two times, but write down the procedure of the sum in your own words. It may be in your mother tongue also. Okay, the scientific reason behind this. If you practice a sum by writing it many times, it will be a mechanical thing then, and your brain will do the sum according to the sum only, but it will forget the general principle. I'll give you one best example for this. Suppose you are doing a quadratic equation, that is solving a quadratic equation by factorization. There you might be practicing a sum which has coefficient of x square as 1. Suppose in exam one question is given wherein you will get the coefficient of x square some other number. At that time your brain will get confused. Okay, so instead of, if you practice the procedure of performing a sum wherein you will get a clear instructions what to do if coefficient of x square is a some number, and what to do if coefficient of x square is not given. Okay, in that way if you practice, it will be very helpful. So tip you don't forget, that is, instead of practicing a sum many a times by writing, just write down the procedure in your own mother tongue.